Alright, welcome again to this video where we will be discussing some of the activities that have to do with volume and surface area. Now you need to go through the examples that are in this document that we are dealing with so that you can understand what has must be done and do those examples as well. You also can look into the previous video where I discussed the perimeter area, surface area, and volume. Now let's get right into it. Let's look at activity 11. It says rainwater falling on the roof of a house can be harvested into a tank as shown below. The tank in the picture has a diameter of 70 millimeters and a height of 1.84 meters. So we have a tank here, and this tank is a cylinder. So I'm just going to complete a drawing of a cylinder here. Now a cylinder, it has a circle at the top and a circle at the bottom, and so we will have a center of a circle, and in this case we are told that it has a diameter. So the diameter of a cylinder will be a line from the circumference through the center of the circle to the circumference. So we are told that the diameter of this cylinder is 760 millimeters. And so because when you look into 11.1, it says calculate the volume of the tank to the nearest liter. So something that we must take into account is that 1 meter is equals to 1,000 millimeters, whilst 1 cubic meter is equals to 1,000 liters. So at the beginning of this document, this is where this information is found. So you can go and revise it. Now we need to also talk of the radius. In fact, before we talk about the radius, we need to talk of the conversion here. So which means the diameter in terms of the meter, the diameter will be 0.76 meters, because 1 meter is equals to 1,000 millimeters. All right. Now let's now talk about the radius. So the radius will be the distance from the center of the circle to the circumference in any direction. So in this case, the radius will be half of the diameter, which is 0.38 meters. All right. And then we also have to talk about the height of the cylinder. So h will be equals to 1.84 meters. All right, that's it about analyzing this cylinder. So let's do the calculation. So it says calculate the volume of the tank to the nearest liter. So they gave us the formula. Volume of the area is equals to half base times the height of the cylinder. Volume of the cylinder is equals to area of the base times the height. In one of the previous videos, I've discussed that the area of the base times height is actually the formula for almost every volume of any kind of a solid. Now let's stick to what we know. We know that the volume is equals to pi r squared h. So this is the volume of the cylinder. But if you look at closely, you'll see we have pi r squared. Pi r squared is actually the area of a circle, because it has the base of this is a circle. The base is a circle, so that's why this volume here, it says area of the base multiplied by the height of the cylinder. So it's not something new. So let's just substitute here. So we'll say pi is 3,142 multiplied by the radius, which is now 0,38 meters squared multiplied by the height, which is 1,84 meters, and this should give us a total of 0,83 481. I'll take two more because this is not the end of the question. 48168 cubic meters or meters cubed. Right, so that's it here, and now we need to convert this into liters. So remember, 1 cubic meter is equals to 1,000 liters. So what we will need to do here is to say one here, which is 0,83488168 multiplied by 1,000 liters. So this should give us a total of 834,81 liters, which we will round it off to 835 liters. I hope you can see. I've clustered so many things in one small area, but I hope you can see that. Now, so we have answered 11.1. Now let's go to 11.2. It says the capacity of the tank is advertised as 750 liters. Explain why this answer is different from the one calculated in 11.1. Now, this question has nothing to do with the calculation, but rather it has to do with understanding of why we do things in real life, the way we do them. So if you go to any container, be it the one for a soft drink, cold drink, you'll see that if you look at the bottle is not full to capacity. You look at a carton of milk, is not full to capacity. So there's a bit of gap or space that is left. Mostly it has to do with safety. So it has to do with safety because when you store these things, you just don't want them to burst and to explode. So you make sure that you leave a little bit of room for the liquid inside or whatever that is inside to be able to expand. Sometimes it produces air that can pop open. So that's why sometimes you would say you will not fill it to maximum, but you leave a little bit of space. So it is for safety. So maybe the manufacturers can say, no, we guarantee you that if you fill it up to 750 liters, the container will perform safely. But if you pour more than that, we cannot guarantee that. So there could be expansion. So you know that if you fill a bottle to the maximum and you put it into a deep freezer, if the bottle freezes, the water inside freezes, then it expands and then it breaks the container. There could be air or air bubbles or air that is produced. So air could push the limits of the container. All right, that's all that I could say about it. Now let's look at activity 12. In activity 12, a man is remodeling his garden and decides to create a simple swimming pool. He plans to dig a rectangular hole and line it with spray-on cement. You may use the following formula. Volume is equals to length times breadth times height. And so we see that we have a swimming pool here that is a rectangular prism, whilst we also have a tank which is a cylinder. And we're told that this tank holds 5,000 liters. Now, one of the things that we should also understand is that 1 cubic meter will be equals to 1,000 liters. So which means if we have 5,000 liters, guess what? It makes 5 cubic meters. Now, let's go into the calculation. 12.1. Use the measurements in the diagram alongside to calculate the volume of the pool. So, we say the volume, since it's given as length times breadth times height, we then substitute and we get the volume as 5 meters multiplied by 3 meters for the breadth multiplied by 1,5 meters for the height, which should give us 22,5 cubic meters. Right, so that's what it means here. Now the next question, it says during winter, he plans to pump all the water from the pool into a storage tank, such as the one in the picture alongside. The large storage tank can hold 5,000 liters of water. If a full tank was emptied into the pool, now so the water will be pumped out to this one here, and then so this is during winter, and then probably to clean so that he can clean the pool. Then once it's done, then he'll pump back the water back to the pool. But now notice something, he will be pumping 22,5 meters out, but this one can only hold 5,000 liters, which is 5 cubic meters. So the rest of the water will be poured out. But then when he tries to fill back the tank will not be full. I mean, the swimming pool will not be full to capacity again, because most of the water that he had to pump out did not go into the tank. Only 5 cubic meters can go into the tank. All right. So it says here, the large storage tank can hold 5,000 liters of water if a full tank, which means if a full tank which has 5,000 liters is emptied into the pool, how high would the water level be? So now if you know water, the water will still occupy the same length, will still occupy the same breadth, but it will not occupy the same height. So probably the water will be full up to a certain level here. So it will not go up. So the water will be full up until here. Okay, so now let's have a look at it. We know the volume because the volume now is going to be 5 cubic meters. So we say the volume is equals to length times breadth times height. Now in this case, we have 5 cubic meters. We know the volume. We also know the length, which will still remain as 5 meters. And we know the breadth, which will still be 3 meters. But we don't know how high the water will reach, so we'll leave it as h. So we have 5 cubic meters is equals to 5 times 3 gives us 15. Meter times meter is meter squared multiplied by height. Now, because we're looking for the height, so we'll divide both sides by 15 square meters, 15 square meters as well. So we'll be left with 15 square meters divided by 5 square meters divided by 15. So this will give us so we will be left with 0.33. Now it will be meters is equals to this side 15 will divide 50, so we'll be left with the height. So therefore the height of the water will be 0.33 meters. So which means the water will only go as high as 0.33 meters. Okay, so I hope it makes sense to you. Activity 13, it says here a mathematics teacher is making teaching aids for a lesson on measurement. She draws shapes, paints them, and sticks them on the classroom walls. The shape below illustrates one of the teaching aids. Now, first we need to analyze this diagram. This diagram is made of 3 rectangles. So it's rectangle A, B, and C. Okay, so there is no name for this shape except that it is a composite shape, which means there are 2 or more shapes that are put together to create this one shape. Now, since we know properties of a rectangle, we know if it is 40 centimeters this side, so it will be 40 centimeters as well this side. All right. And then I want to also look into this one here. If it is 20 centimeters this side, so which means we will also have 20 centimeters as well this side. Now this whole side here, sorry about that, I didn't need to come out that one. So if we have 20 centimeters this side, so we can also have, and this side is 60 centimeters, so which means this one here will be 40 centimeters. Okay, and opposite this one will be 40 centimeters as well. So this side here is 100 centimeters, which means this side is also 100 centimeters. Now we already have 20, 40, so we'll need another 40 to complete it to make it 100 centimeters. Now we have 60 centimeters this side, and therefore this side will also be 60 centimeters. Okay, what else is missing here? So I think we have all the sides. Oh, this side is 120 centimeters on rectangle B. Excuse me. So, which means this side also must be 120 centimeters. So, which means this distance here will be 60 centimeters, so that it can be complete 120 centimeters. Okay. Now, that's what we have done there. So let's try to answer some of these questions. A learner uses a string to measure the perimeter of the shaded figure. What is the length of the string? So they are asking us for perimeter. So perimeter, we know perimeter is the distance around the shape. So we'll simply add this side here, which is 100 centimeters, plus this one here, which is 40 centimeters. I'm not writing the units because the units are all the same as centimeters, just to keep it a little bit clean. So plus 40 again, and this one here, which is 60 plus 20 plus 60, and going all the way here, which is 60 plus 120 plus 20, and finally we have 40 here. All right, so this should give us a total of 560 centimeters if we have added everything correctly. In 13.2, calculate the area of the shape in square meters. Now they want the area of the shape in square meters. Now we said that this is shape A, or rectangle A, rectangle B, and rectangle C. So let's deal with them separately. So we'll say area of rectangle A will be equals to, so we know it's length times breadth, so we'll simply substitute there and have 100 centimeters multiplied by 40 centimeters. Okay, but now if you look at the rectangle A, it has 40 centimeters and 100 centimeters here. Now we need to convert these units into meters. So we know that 1 meter is equals to 100 centimeters. So which means we divide this 40 by 100, so we'll get 0.4 meters, and this 100 we divide by 100, we'll get 1 meter. So in other words, in our calculation here, we'll, instead of having 100 centimeters, we'll have 1 meter multiplied by 0.4 meters. Okay, so this will basically give us 0.4 meters. And we do the same for area of rectangle B. Let me use a different color for it. So this will be area of rectangle B, since it's also length times breadth, we will then say the length is 120 centimeters multiplied by the breadth, which is 40 centimeters. So it is the 120 multiplied by the 40 centimeters. I'm just realizing something here. We have 20 centimeters, and this one gives us 40, so it must be 40 here, which means if we have 40, 20, 40, 40, so that makes it 100, so it shouldn't be 60, it must be 40 centimeters. So excuse me a bit. All right, so which means we have 120 centimeters divided by 100. So to change it into meters, so we'll have 1,2 meters multiplied by 40 divide by 100. So this will give us 0,4 meters. So if you don't understand the conversion, you can go back to the beginning of this document where conversion is done and see how it should be done. I'm just now assuming that you are now able to do the conversion. That's why I'm moving quickly, because that's the gist of this calculation. So in this calculation, therefore, which means we will get 0,48 square meters. Okay, 0,48 square meters. Now I also want to use a different color for the next shape, which is C. So for area of shape C, we have the length, which is 60 centimeters multiplied by 20 centimeters. Again, we do the conversion, which will be 0,6 meters multiplied by 0,2 meters, and this should give us 0,12 meters squared. So we now know the area of A, area of B, and area of C. Now let's calculate the total area. We'll say total area of a shape is equals to 0,4 meters for area A plus this one here plus 0,48 for area B plus 0,12 for area C. So this should give us a total of 1 square meter. All right, so this is what we get for this calculation. Please do excuse me, I am battling some flu, but you shouldn't worry much. I'll try my best. In 13.3, excuse me, in 13.3, she prepared 2 of these shapes for the class and paints the shape with 2 coats of paint. So there are 2 shapes, okay? Which means now the total area that needs to be painted for 2 shapes, it will be for two shapes will be 2 times 1 square meter, and this will give us 2 square meters. Really easy. But now the number of coats, so total area for 2 coats now, meaning you'll be painting the same thing twice, so it will be 2 times 2 square meters. So if you're painting same thing twice, it means you are painting the area double, so you'll have 4 square meters. So that's what it means here. Then we are told 1 liter of paint covers 6,2 square meters. Now we'll go back to what we know. If we read a statement like this, we say 1 liter is to 6,2 square meters. But we don't have 6,2 square meters. We have how many square meters? We have 4 square meters. Which means, therefore, this will be the amount of paint. That's what we are looking for. So we'll say paint will be equals to, by cross multiplication, where we'll get 1 liter multiplied by 4 square meters divided by 6,2 square meters, and this would give us a total of 0.32258 liters. So this is the amount of paint that is needed. I just need to confirm this by my calculator. So we have 4 divided by 6,2, and I'm afraid I've been incorrect, so this should give us 0.64516 liters. So I'm taking a little bit more of the decimals after the comma because this is not the end of the calculation. Now, moving right along, the salesman at the hardware store stated that 500 milliliters of paint can 500 milliliters can of paint is not enough to cover the shapes as needed, meaning it will not be able to cover 2 shapes and coating them twice. So you need more paint. So it says verify with calculations whether he is correct. So from here we'll say the paint, now we need to compare milliliter by milliliter, so which means the paint will be 0.64516 multiplied by, now 1 liter is equals to 1000 milliliters. So we'll simply multiply this by 1000 milliliters. So this should give us 645.16 milliliters, or simply 645 milliliters of paint that is needed. Right, so you cannot buy 1 can of 500 milliliters, so you'll need to buy 2. So we must conclude now. It says verify with calculations whether he is correct. So we need to conclude and say the salesman's calculation were correct. You need 2 cans of 500 milliliters to cover 645 milliliters needed. All right, so that's what this calculation means, and that's just about it. So please, if you have not done conversions of unit, go back to the beginning of this document and see how conversions of units are done. All right, so please do that. And secondly, if you are not aware of what these calculations entail, which have to do with area, perimeter, volume, and surface area, please look at the previous examples before activity 11, and you'll see how they are done, and look also into the previous videos. All right, see you next time. Thank you for watching.